All right, so I think I'm recording. Let's take a look at this problem. They want us to simplify the square root of 15 times the quantity, square root of 10 plus 4. So we have a single factor outside that square root of 15. And the second factor, it's a binomial. It has two terms. With multiplication, there's a property in mathematics that's called the distributive property. And what it allows us to do is to multiply a single term like this times something that has more than one term, because multiplication distributes over the addition. So what this property tells us, that we have the square root of 15, and we're going to multiply that times that first term, the square root of 10. And then the multiplication distributes over, it jumps over the addition, and we have the square root of 15 times 4. Well, when we have two radicals like this that have the same index and you have multiplication, we're constantly breaking apart, but remember, we can also put it together. So these two radicals can be written as a single radical because we have multiplication. Now over here, we can multiply in any order. They call that the commutative property. If you have an A times a B, it represents the same number as B times A. The order of multiplication doesn't matter. It does in subtraction and division, but it doesn't in multiplication or addition. All right, so I can write this as 4 times the square root of 15. Now, can we break down this first radical? I don't, well, I do know 15 times 10 is 150. But rather than multiplying this together, what I'm really interested in is how it breaks down, how it breaks apart. We know that it's 15 times 10 because that's how we got the 150. We know that 15 breaks down to 3 times 5, and we know that 10 breaks down to 5 times 2. And here we have found a pair. So what this is telling us is that we can simplify the square root of 150, and that we can write it as 5 times 5 times 2 times 3. And one of these properties of radicals, when you have multiplication, that we can split this into two radicals, that we can write the square root of 5 times 5 times the square root of 2 times 3. So the square root of 150, this first factor is just an ugly way to write the number 5. 5 times 5 is 25. The square root of 25 is 5. See, whenever you have a square root, you're looking for pairs, and we found one. So we just write that one factor out there, that 5. Now, with the 2 and the 3, I don't have another 2 or another 3. I don't have a pair of 2s. I don't have a pair of 3s. What I can do is just leave this number 2 times 3 underneath the radical, and 2 times 3 is 6. So let's come back over here to this first term. What does this tell us? Well, it tells us that we can replace the square root of 15 times 10, which we know to be the square root of 150, that we can replace that it's equivalent to 5 times the square root of 6. But we can't do anything else with that. And like we say, it's easy to see that the 15 breaks down to 3 times 5, and you can't do anything with that. So our final answer has two terms, and they're unlike terms. I can't combine them. This first term, that 5 is counting how many radical 6's that we have. And the second term is counting how many radical 15's that we have. And the radical 6's and radical 15's can't be combined. Not with addition here. These are unlike terms. So there's my final answer for number 14, and I hope that helps. I will talk to you later. Bye.